No, it's just like some sample questions. Yeah, no worries. You're all good. Yeah, I'm going to go print one more for you. Yeah, no worries. Yeah, you can just.
That's what I'm saying. The keyboard. Yeah. No, wait. Actually, yes, because it already gives you the quarter and pumps.
Yeah, because it's less than one. Yeah, I think that's right.
Yeah. Did you get 6.125 times the negative?
Hold on real quick. Hold on.
It's like the order of
Double. Just for us to show.
Accumulated side by side.
Outside.
Is every other, and then isolated is yes. I believe so. Right. Yeah. I mean, I should probably check, but that's what I remember. It's talked about like you really know what was up. Just kidding. How do you use alternate? Which one did you have? Kino? Was that it? Yeah. Double bonds are right next to each other. Yeah, non-conjugated or isolated is more than one single bond. Yes, they're high next to each other.
Oh, okay.
Now you have extra.
What's that?
Now you have extra.
Yeah.
Okay, I think I set it up.
Okay, how is it going?
It's alright.
Good? Okay. Yes.
No, sorry.
Oh, okay. So as I mentioned, because now I wasn't recording the lecture before, so now I'm recording. As I mentioned, these questions that you're seeing now would be really similar to the questions of your quiz 3. And this is the advantage of you coming to the class today because you have these questions. So I expect people who are not in the class and watching the lecture reach out to me, so I send them these problems. So now in this way I know who is really watching the lectures and who is not. Does that make sense? Okay, so yesterday I was thinking to maybe assign extra credits for you to accomplish this quiz, but then I thought that it's maybe better that I post a video going through the problems so you have the solutions. So for that matter, I can also assign extra credits for you to complete this because I know if you answer the questions correctly, I know that you watched the lecture. Does that make sense? So how many of you would like to have extra credit to accomplish this? Okay, all of you, okay. So I assign 20 points for anyone who complete the quiz, okay?
By when?
And since I'm going to, what's that?
By when?
By after the break, so Monday class, okay? So I can just make the deadline like Monday night, like Monday 11:59 p.m., like our other deadlines. So you have like one more day after the break too. Does that fair to everyone? Or do you think more time? Yes.
Right, so that's right.
So that's a good question. So I think it's good for you to have your solutions. So after you finish the quiz, if you can just like take pictures of your solutions and just have that, if it's possible for you, I really appreciate it. If you just merge all the photos and then have it as like one PDF document and just email that to me. And since there are like right now, there are like 40 of you exactly in the class, and I'm not sure how many more complete that, but still, even like 60 of you do that, it's not that hassle for me. And I don't want to generate something on Canvas to create confusion between quiz 3, because quiz 3 is mandatory, it's like 40 points of your grade, but this is something extra that I highly encourage, and if you don't do it, you don't lose any points. But I assign 20 points for this, so if you miss some points for exam 1, or you didn't do like 1 or 2 homework assignments, this totally cover for that. okay? And since I'm going to post the solutions, you know, I post a video of me going through the problems, I expect you all to have all the questions right, okay? But if you have like 1 or 2 minor errors, that's not the biggest deal. I still give the credit. But one thing that I don't want to happen is that you just like copy answers from your friends or not solve the problems, because that is not the point for this, okay? So don't do that. And I was a student, you know, I saw we were doing similar things, you know, so if I see 2 homeworks just exactly similar, I know what happened, okay? So don't do that. I feel like you have lots of extra credit opportunities, and the course is not, at least the structure, grading and everything is not that difficult, so there is no point to do academic dishonesty, okay? Any questions about the quiz? Are we clear on that? Okay, so before continuing with the quiz, let me finish the lecture that I had for the last class, and then afterwards, just realize this is like that because projector is so screen now. It seems like people just thought that break hasn't started, so okay, cool.
So I'm still gonna write it out.
Okay, so let's do the attendance real quick. So
I know, it works so fast on my phone. It just makes me so happy.
Yeah.
Yeah, so I don't like it when people just put it so
yes.
If we end up needing like more space, is it okay if we write on a different sheet?
Yes,
of
of
paper and
course.
just
Yeah,
write
yeah, yeah.
separate?
I just wanted to save paper,
Okay,
so I
perfect.
had like kind of questions packed. But yeah, feel free to just write on anything. So as long as you give me the solutions, that's all I care about. Okay, are we good with the attendance? Okay, so just briefly summarizing what I mentioned before in the previous session. So we have 2 concepts, reaction, thermodynamic. The other is reaction kinetic. And I asked you also in the quiz sample problems that I gave you. So thermodynamic tells us whether or not a reaction occurs. So we said there are like 2 different factors. One of them is enthalpy, entropy, and then depending on interplay of these 2 parameters, we can say whether or not a reaction occurs, okay? And we had like some definitions, as I just mentioned, and we defined how we can recognize entropy change by chemical reactions. Can anyone tell me how did we do that? So if I give you a reaction, I said, does entropy increase or decrease? How do you say that?
Based on the number of moles on each side?
Exactly. And some materials or some states, they have like more entropy, like gases, right? Because the molecules can move more freely compared to liquids or solids, right? And we went through some examples, and also there was a way to connect equilibrium constant and Gibbs free energy. And Gibbs free energy was defined by this formula, right? And this is another question that I asked you in sample quiz 3 problems. And most of the time, if you see something that I asked for a definition, you can just find the answer from the slides, right? So here is the formula in which we connect equilibrium constant with Gibbs free energy. And this is how we defined equilibrium constant, or how we calculated that. And in the first question that I gave you, I asked you to use this formula, and this is basically reverse of what we solved in the class. So in the class, I gave you each of these parameters, right? And this A, B, C, D, you can get from like the balanced chemical equation, right? So now in the first problem, I asked you the reverse. I gave you K equilibrium, and then I gave you 3 of these, and then asked you to find the 4th one. Okay, are we good with these? Clear? Okay, and then we said when reaction occurs, or like if you have like AA plus BB in, equilibrium with CC plus DD. And the other thing to mention is that I use the expression in equilibrium, but can anyone tell me when these 4 substances, or like reactants and products on both sides, they are actually in equilibrium?
The equilibrium constant is 1.
Exactly. So if equilibrium constant is greater than 1, right, we said reaction proceeds from left to right, right? And then if it's less than 1, it proceeds from right to left. But if it's exactly 1, it means that we have no reaction anymore, right? And then the concentration of A, B, C, D remains constant. So they are in equilibrium. And if we have some reactions that they are only go AA plus BB gives CC plus DD. They don't proceed the other way. It just goes one way. And we call these reactions irreversible. Irreversible, if I spelled it correctly. Reversible, right? It means that the reaction doesn't go the other way around. So in previous classes, we were just saying that reaction goes left to right, right to left, okay? But if the correct term, or like another way to put it, is that if reaction just goes left to right, it means that it's irreversible. It means that the reverse won't happen. But if we have like both arrows, it means that the reaction is reversible. It means that not only A and B produce C and D, also C and D react and produce A and B, right? For instance, combustion reaction. If I burn some piece of wood, do you think that reaction is reversible? No, right? I mean, if it was, it would be really interesting, right? It would be kind of magic. I burn something, it just like disappears, and then it's just like ashes and carbon dioxide, and then I see it's kind of like carbon dioxide, and the ashes, they react again and then generate the wood or whatever I burned. So some reactions are not, reversible, and we call them irreversible. But there are certain reactions, like examples that we gave before in the examples, they are reversible. So, any questions? Good. Okay. We also talked about endothermic, exothermic, okay? And I also told you that here, the correct term here, it would be like if K equilibrium greater than 1, that corresponds to delta G negative, and then if K equilibrium less than 1, it corresponds to delta G positive. So your book didn't consider the effect of entropy. That is not quite correct. But again, the reaction coordinates and also the reaction diagram is correct. If we have like delta H negative, we have like reactants here, products here, and products have lower energy. And the same thing for delta H positive. If delta H positive, it means that heat is being absorbed, so products have higher energy. And this is another question that I asked you in the quiz, sample quiz. That what is delta H negative, what is positive, endothermic, exothermic reactions. Are we good? Questions? Okay, now today's lecture. We want to talk about reaction kinetics. So as I said, with thermodynamics, we can say with equilibrium constant or with changes in Gibbs free energy or considering enthalpy, entropy, we can say whether or not a reaction occurs. Or if we have a reversible reaction, we can tell does the do reactants combine with each other, react with each other, and produce products, or vice versa, or which one we have more. But we cannot say anything about the speed of reaction, right? You can just tell me if, delta G is negative, you can say that reaction occurs, right? Or if delta G is positive, it does not occur. But you cannot tell me how fast it is. So that's why we should also study reaction kinetics. So kinetic means speed, right? Have you ever heard of kinetic energy? Right? So kinetic is kind of deals with like speed or rate of a reaction. Okay? And so this is, as I said, another question that I asked you in the quiz. That what is the difference of these two? So this is the difference. And also, in order to study reaction kinetics, we should learn some terminology. One of them is activation energy. And if you remember, like 2 or 3 times during this class, I had like some graph like this, right? And then talked about like activation energy a little briefly, remember? So activation energy is an energy barrier that we should overcome in order to get the products. Do you remember that if I have like piece of wood here or like ethane, methane, some fuel or gasoline, and then if it's just here, we have oxygen in the room too, right? But it doesn't burn by itself, right? We should give it a spark because these reactants, they should reach an activation, they should overcome some barrier, or specifically energy barrier. And we call that activation energy. And this activation energy for different materials is different. So for pure hydrogen, this activation energy is really low. That's why if we have a tank of hydrogen here, we should be really careful because with smallest spark, it just like explodes. But if you have ethanol, we don't need to be as careful, right? Or like if it's gasoline, so this activation energy would be higher. But for some materials, this activation barrier or activation energy is really low. So we should handle those chemicals more carefully. Does that make sense? Okay. And the activation energy is what determines the kinetics of the reaction. The higher the energy hill or this activation, this barrier, the slower the reaction. Does that make sense? Any questions? Okay. The other thing is transition state, which is really close concept to activation energy. But the definition is that if we have like this energy diagram that I showed you just before, and if I have reactants here and then products here and here, we have like energy, right? So here at this very top here, you have like your activation energy, right? Activation energy. So here at this top in the energy diagram, where you basically have, if you construct activation energy or see where it is, at here we have transition state, which is basically, it's the point that bonds of reactants are being broken and still they didn't form the products. Does that make sense? So at this point, atoms are really unstable because they just broke their bonds and now they want to form, they want to bond again to form products. And that's why their energy is really high. As you see in this energy diagram, if you see like different energies, the numbers for transition state, this number is highest. And do you remember, based on what we talked about in this class, do atoms and molecules or all species, do they want to have highest energy possible or lowest energy possible? Lowest, right? So that's why when you have like your species here or like your atoms that they broke their bonds, now they have like really high energy, so they want to react, so they want to form bonds again and reach much lower energy state. Okay, so kind of like going through your book, we say at the very top of the energy barrier, the reaction is at its transition state, which is the point at which the bonds are in the process of breaking and forming. So the bond has been broken and they didn't form the bonds yet, so you don't have the structure of the products yet. It's the point that bonds has been broken and now they are in the process of forming bonds. That's why the energy is really high. Does that make sense? Questions? Okay, and I also have, like, as I said, anything that I get from resources outside your book, I have the link here so you have the chance to study more and see, more of the subject. Because I have just like definitions that I took from different resources and just really short. And so you're expected to read the book, but also if something that I thought it's good to have like more information on, you're welcome to also look at those links that I posted. So again, reaction rates, it means that how fast is a reaction, right? We're dealing with rate or speed of a reaction. And here is basically a summary of what I just said, but I thought it's good to have also them written in text. So equilibrium constant just tell us whether or not products are more stable than reactants. It means that if products are more stable, probably they don't want to form reactants again, right? But if they're not, products are not as stable, they want to form reactants again. Or in general, equilibrium constant tells you which direction the reaction goes, right? But equilibrium constant does not tell us anything about the rate of the reaction. And this is something that for sure you're going to see in your quiz 3, whether it's like true or false questions, or like which of the following sentences is not correct, or which one is correct. So make sure to know. If you know the difference between thermodynamics or equilibrium constant and reaction rate, I think the questions would be fairly easy. And chemists use reaction energy diagrams to show the changes in energy that occur in the course of a reaction. This is basically this energy diagram that we showed before, right? So is this reaction that I have here, is this endothermic or exothermic? Exothermic. So how did you say that?
It releases energy into the environment, so it loses energy.
Exactly. So you compare the energy of reactants, and here you have reactants, right? So I can do this. Here you have products. So you compare, if the energy of products is lower, your reaction is exothermic, because your system lost energy to the surrounding. Now products have lower energy. Does that make sense? What about this one? Endothermic or exothermic? What's that? Endothermic, exactly. Endothermic. Here you have like reactants, you have products. So reverse of what we just said. Okay? Any questions so far? Okay. So this is kind of like explanation of what I just said, just like in more nicer version, I guess. So here I give you this in your quiz, and then I have like these guys blank, and I say, you know, I have like this A, B, C, D, E, and I say which one represents which. So make sure you know these well. I guess I can here give you energy and reaction coordinates too. E, F, G. So make sure you know these reaction diagrams well. Okay? And here is a link from Khan Academy that again explains the difference between thermodynamics and kinetics. And I encourage you to watch that. It's just like 15 minutes video. So I think it's really useful to understand these concepts even better. And then if the link wasn't working, you can just let me know. It should work. Okay, now we want to talk about a principle named Le Chatelier principle. Have you ever heard of this before? Okay. So far, one type of reactions that we considered was reversible reactions, right? That we have like the arrows on both sides. It means not only reactants produce products, products also react and then they produce reactants again. So the Chatelier principle basically says that if you add a reactant here, right? If you add more of one of your reactants, the reaction wants to compensate for what just happened, okay? So here in this reaction that I have here, if I add more of A, whether like more moles or like more grams, depending on what units are, what we are working on, or what measurements we did. So if I add more of A, this reaction wants to compensate for what happened. So what do you think happens? Do you think reaction goes left to right or right to left? Left to right. Does that make sense? The principle itself. So it means that if you change the system wants to kind of fight back in a sense. So if you add more of A, the reaction occurs or like proceeds in a way that compensates for the fact that you added more A. So in order to decrease the amount of A, the reaction should go left to right. Okay? So what do you think happens if I add more of D? Yes, reaction goes right to left. Because if I add more D, right, the reaction goes right to left so that it compensates for this fact or kind of consumes D. So now imagine if I change the color here to this one, I guess. Okay, so now if I remove some C, what happens then? How many say left to right? How many say right to left? So why right to left?
Compensation.
So what did we do?
I don't know. Just guess.
No. What I'm asking, basically repeating the question. If I remove some C, so now C is less. Reaction wants to do something that increases it, right? As if it didn't happen. So how can we increase C? Does that make sense? What I'm
Can you
saying?
replace it?
Yes, so Le Chatelier principle basically says that, and here your book, or rather your slides, they talk about just adding a reactant or removing a product, but it can also be about pressure or like heat of reaction or other concepts. So in general, when you change your reaction or reaction conditions, reaction proceeds in a way to compensate for that, as if it didn't happen, right?
So it's still go left, right?
Left to right, exactly. Because if you remove some C, you want to generate more C as if it didn't happen. So your reaction goes left to right. So this is basically what is the Chatelier principle. And this is actually what some people do, or some manufacturers do in industry, that if they want to have more of one of the products that they're producing, what they do is that they keep removing that from their reaction vessel. So more of that will be produced. So they take advantage of this principle. Okay?
So
And
if something is removed, do you have to add more to the reactant side in order to compensate for that?
so here when we have like certain amount of reactants on products, reaction, I mean it depends on the reaction that we're studying, so in nutshell. But in general, if you remove some of the C here, reaction automatically goes left to right, but you should have enough of your reactants and products, you know, and it depends on the reaction rate and also the amount of, you know, reactants and products that you have. Because if you have like really a small amount, maybe reaction occurs more right to, or like if it occurs more left to right and you have like really small amount of your reactants, at some point your reactants and products, they finish, or I guess your reactants. I mean, depends on which direction reaction proceeds more. Does that make sense? Great question. Any other questions? Okay, and here your book gives some example of like some reaction here, and then it says that adding ethanol or removing water, so you have water here, and then you have like, you know, this alcohol here, and it says, you know, adding ethanol, if you add more of this, or removing water, if you basically decrease this or increase this one, will drive this reaction to the right. Because if you decrease the amount of water, right, your reaction go this way to compensate for that. And also if you increase this, you know, reactant here, again reaction goes this way to compensate for that. Does this make sense? Questions? Okay, so I brought some examples here. Imagine this reaction here, CO2 plus H2 goes both ways, is a reversible reaction, H2O gas plus CO. I guess all of these are gases. So if I guess I write it as I wrote here, a drying agent is added to absorb H2O. So I asked you which direction the reaction goes, left to right or right to left. Yes, so if I add a drying agent to absorb water, it means that the concentration of water is decreasing, right? So if this one decrease, your reaction go this way, so water concentration increases. Does that make sense? Okay, let me go to the next example. If we have H2 gas plus O2 gas goes both ways to HI gas. And I say some N2 is added. So we add some nitrogen to this reaction. And I ask you, does reaction go left to right or right to left?
Which side is it added to?
What's that?
Which side is the nitrogen added to?
So we have like a reaction vessel that this reaction occurs, and then we just add some nitrogen to our reaction vessel.
Also, would it go left to right?
What's that?
Would it go left to right?
Why?
Because you're adding it to the reactants. Or you not?
It wouldn't change because like N's not involved in that equation.
Yeah. So if you add something that doesn't participate in your reaction, it doesn't do anything to the reaction. Right? So nothing happens in this case. Does that make sense?
Question.
Yes.
So for this top one, if you didn't have the drying agent or anything, which way would the reaction go? Like if you weren't changing it?
So if I just was given the reaction and was not being told anything, the reaction would go both ways based on how I wrote the reaction.
Okay.
Yeah. Great question. Any other question? But most of the time in exam, I add an effect and then ask you what happens, because otherwise, just like what we see. Okay. Let's have quickly another example. NaCl solid plus H2SO4 liquid, Na2SO4 solid plus HCl gas. And I say reaction is carried out in an open container. And then I asked you, reaction goes left to right or right to left? Yes, why?
Because your HCl gas is heavily.
Exactly. So if I do the reaction in an open container, the reactants and products that are liquid or solid, they just stay, right? Nothing happens. I mean, they won't leave the reaction vessel, right? But this HCl leaves the reaction vessel, right? So it decreases. So when it decreases, in order for us to compensate for that, the reaction should go left to right to produce more. Does that make sense? Okay, let's have another example. And I write AgCl solid equilibrium, or like the reaction is reversible. Ag aqueous plus Cl aqueous. And I say some NaCl is added to the solution. What do you think about this one? Right to left. Why?
Because it's a solution has to be a liquid, so that ACL is going to get added to that side.
Mm-hmm.
It has to push to the left then.
Exactly. So when we have another salt being added to our reaction vessel, and remember, when we have aqueous, these yes, so they are basically dissolved in water. And if you add NaCl, NaCl also produces Na plus Cl minus, which both are aqueous, right? And NaCl is solid. So now you're increasing the concentration of chloride ions, right? So since now this is increasing, your reaction goes right to left to compensate for that. Does that make sense? Okay, finally, let me have like another example. Say N2 plus 3H2, 2NH3 gas. And I say a catalyst is added to speed up this reaction. What happens now? Left to right, right to left.
Could go either way.
What's that?
Could go either way.
Could go either way. What else do you guys think?
Would it change at all? Like, just because it's just speeding up the reaction?
Uh-huh. Yes. So this is like the difference between thermodynamic and kinetics that we said, right? So when we're dealing with left to right, right to left, we're dealing with equilibrium constant, and we're not dealing with the speed, right? Remember? So if we add a catalyst to increase the reaction speed, and even if I don't tell you to increase the reaction speed, you know this is what catalyst does, right? So it just increases the speed, but it doesn't change the thermodynamic of the reaction. So nothing happens here. What I mean in the sense of left to right, or right to left, right? So something happens, the reaction goes faster, but it doesn't change the equilibrium constant or the way that reaction proceeds. And I also write another example for you all. This is similar to what we said before. I say water evaporates from an open container. So this is not a chemical reaction, but it still is a physical change, but still we have like the Le Chatelier principle. So if water evaporates from an open container, its concentration is decreasing, right? Exactly. So if this decreases, reaction goes left to right. Okay. So before you all go, remember that you have one homework and one quiz due the Wednesday after the break. So I encourage you to just, as soon as I post it, I try to post it like sooner than later, but start studying for the materials. And also remember to solve the sample quiz 3, even if you don't want to hand it in, which I think, it's better for you to do that, especially because I'm going to post the solutions, right? So it's just 20 free points. But yeah, make sure to work on these problems before doing your quiz. Thank you.
She said she at least got like a 65.